Hello, in the previous video, we have already discussed about some problems which was solved using DFS. But in this video, I will include one problem that was discussed by or that will be discussed by BFS approach and some to solving some problem. That means if you are trying to solve some problem, then you can't solve using DFS approach, and that type and some problems only can be solved via BFS. So let's discuss. This is one of the lead code problem. Question number 54201 matrix. So let's let's understand what is the problem, okay? And I want to say that this problem if you try to solve this problem using DFS, then there may be chance that the solution will be wrong. So for clarity, first I want to take one example so you are able to understand why DFS approach will be not applicable in some question. Okay, actually the if you have given that find the minimum step to reach the target, that means minimum distance between two nodes. That type of minimum distance problem is generally solved by BFS approach. Let's show an example so you understand. If one example is like that, and let's assume that all the edge length of one unit 0 1, let's name 3 4 5 and 6. Let's that means edge length of one unit. Okay, and the question is that find the find the least distance between that means find the least distance between node 2 and node 6. Okay, node 2 and node 6. Okay, so the what will be the actual answer? The actual answer will be this distance, and the edge all is of 1 unit, so the answer will be 1 unit will be the correct answer. But if you try to solve this problem using DFS, that means what is the minimum distance between node 2 and 6? If you try to start DFS call from if you try to start DFS call from 2, let's first make DFS call from 2, okay, and make value. If you try to travel, then try to make one value for every node, okay. If you try to make DFS, if you try to make if your DFS call will start 2 and then after you call the child of 2, that means if you start from 2, then child of 2 is 3 and 6. So the 2 have 2 child but 2 neighbor, 2 have 3 neighbor, 1 3 and 6. And if you call immediately 6, then your answer will be 1, and that will be the correct. But if DFS call is not ensure that you may call 1 3 and 6. Let's first call go to towards 3, okay. Select this value 1, this one, that means you first visit 1. Okay, now let's you go towards 3, then this is that means distance, this will give the distance, okay. This is till now there is 0 distance. Now if you go towards 3, you travel one edge, and the edge distance is of 1 unit, so now your distance will be 1. 3 will call it for neighbor 2 and 4, but 2 is already visited. Now 3 will call for 4. Now your total distance is 0 1. That means here one distance, now your distance will be 2. Okay, Now 4 try for 3 and 5, but 4 cannot try 3, but 3 is already visited. Now 5 try for 5. Now distance will be, total distance will be 2, 2 plus 1. Now total 3 unit distance is traveled. Okay, now 3 call for 6, and if you encounter 6, okay, now your distance your distance will be 4. So if you try to start DFS call from 2, and if you reach at 6, then your answer will be 4. That means you have to travel 4 unit of distance, and then you able to reach at 6. So your answer will be 4, but this is not minimum distance. You have two path to go from 2 to 6. One is this path and one is via this path. So DFS not ensure that you will follow one path that will be the shortest distance. Okay, and if you unfortunately you first follow this path, then you will get 4 answer, and that will be the wrong answer. That's why I want to say that some problem are mainly solved via BFS. If you try to make BFS call, then BFS call like what? If you try, let's, if 2 to 6, if you try to make BFS call from 2, let's assume 2 is as a center. So 2 is at unit distance, at a 0 distance from 2. Now what is the neighbor of 2? 1, 3 and 6. So the neighbor, if initially let's 0 labeling for 2. Now 1 is at unit what level? This is at 0 level. Now 1 will be at 1 level. This 6 is also at 1 level. Now 3 will be at 1 level. And here, and now if you try for 3 to all side, then 4 will be at 2 level. 5 also will be at 2 level. And now you try from 1 to 0. 0 at be at 0 is at 2 level. So here you will get 6, which is at 1 level. That means it one level showing the distance from 2. So that means here 1 will be your correct answer. So this problem, if you try to solve via BFS approach, thus your answer will be correct always. Okay, so I think there will be some understanding about BFS. Okay, why need of BFS to solve this problem? So let's understand what is actually the problem. We are given a m cross n binary matrix. Return the distance of nearest zero for each cell. The distance between two adjacent cells is 1. Okay, two adjacent cell distance is 1, and you have to return the distance of nearest 0 for each cell. Let's take this example. Second example. Second example of size 3 cross 3. It is 1 1 1 1. Okay, 0 0 0 0 and 0. You have to find the nearest 0 cell. What is the question? return the distance of nearest zero from each cell. Okay, so if you able to solve, then your answer will be okay. We have to find the nearest zero cell. Here this is, so let's start for this. For each cell you have to find nearest zero cell. Okay, for each cell you have to find nearest zero cell. This is the zero cell, so the nearest zero is itself. So nearest zero is itself, that means nearest zero is at zero distance. This is 0, so nearest zero is itself, so the nearest zero is at a zero distance from it. This is itself 0, so nearest 0 for this cell is itself 0, so that means 0 distance from it. Similarly for this cell, nearest 0 is itself, so at a 0 distance from it. Now let's for one, for this, here 1, for this one the nearest 0 will be either this 0, this 0 or this 0, and all are at one distance, because it is given that the distance between two adjacent cell is 1. Okay, that means uh, adjacent cell distance is 1, distance is 1, distance is 1. So for this cell the nearest 0 is at one distance, either you can take this 0, this 0, this 0. Okay, for this 0, this 0 itself 0, so the nearest 0 is at 0 distance. That means for 0 answer will be 0. Now let's one this one. For this one the nearest 0 is this, which is at a distance 1. For this one the nearest 0 is, you can take either this or this both. So the nearest 0 is at that means you can travel one distance, then again travel one distance, that means dot distance. If you take this, then you can again first travel this distance, you can then travel this distance, that means at a two distance. You can also travel one distance and then two distance. Okay, similarly you can travel this distance, or that means nearest 0 for this one, this cell is at two distance, and this cell the nearest 0 is at one distance. So this will be the answer, and this will be the answer for this example. Okay, so let's start approach how to solve this, how to make this solution. Okay, this is your example for solving this problem. This is BFS, so need of, there will be the need of a stack, sorry there will be the need of queue. Okay, and we have to think that this this queue, initially this queue will store which type of parameter. Okay, that means let's assume that if this this is that means this cell is already solved. Okay, if you are at, that means you first fill all zeros, the box or the cell having zero value, the answer of that cell will be always 0. So first fill all the, that means answer of all the cell have the whose value is 0 will be the value, that means answer of, that means in answer array, in answer 2D array, you must fill 0 in those cell having zeros value. Okay, that means first fill all cell having zeros value. Okay, because that the, because if this is the 0 itself, then the nearest 0 will be at a 0 distance from that cell. So let's first put it, this is, this is the answer. Okay, this is the answer. This is the answer. Let this is visited. Okay, visited will, and this is your matrix. So for 0 all the value will be 0. Okay, and if you are at this distance, or if you are at this index, ij index, then you will try for all four neighbor. Okay, all four neighbor. Then you will try for all four neighbor. And if you will try for all four neighbor, and if you are able to encounter one, that means this one be this one value of the answer for this box. If you are able to encounter, that means for this, if you are able to encounter this one, so the answer for this cell will be the answer of this cell plus 1. Okay, because if this 0 is at d distance from nearest 0, then this cell will be at d plus 1 distance from nearest cell. For this purpose, let's start to solving. This is the cube. Okay, this is cube. So in cube, make one class pair class. Okay, let's one pair class, one pair class, let's one pair class. Okay, that will store this pair class having index x y, that means a variable x y and d. This x y is the row number and column number, and d is the nearest distance for that x y. That means if for this cell x is 0, y is 0, and d is also 0, that means xy denote that the cell whose row number is x, column number is y, then the answer for this cell will be d, like that. So and the cell having value is 0, and value having, that means cell having value 0, the answer must be 0. Okay, so first in queue put those cell having value 0 in the form of x, y and d. Okay, in the form of x, y and d. So let's first start from, and that means first travel all the cells, that is make 4 into 4, that means you have to travel from each cell and first to find value 0. Okay, and if you are able to find value 0, if you are able to find value 0, let's if you are able to find value 0, then you have to put this index into distance 0. If you are it let's start. If you are at let's start, if you are at this 0 0, okay, then you have to able to find this value is 0. So let, and the index of this box is x equals to 0, that means row 0, column 0, and the distance, nearest distance, this is 0, so nearest distance is also of 0. Now for this, the row will be 0, column will be 1, and distance will be 0 because it itself 0 value. Okay, so the nearest 0 will be at a d distance, that means at a 0 distance. For this cell, this will be 0 to column, and at a what distance, what is the nearest 0 cell, so 0 cell is at 0 distance. Now for that put row 1, column 0 at a 0 distance. For that here this is 1, so not we can't put in queue. This here 0, and which is at row 1, column 2, and which is at a 0 distance, which is at a 0 distance from nearest 0, and here in no 0, in this row no 0. Okay, so no 0, so we are so we are able to find all the zeros value. So this will be the first step. Okay, now let's try. Now let's try to iterate. Okay, and now let's start BFS approach. What's first? This is Q is first in first out. So remove first this, and the value will be 0 0 1. So the x value will be x value. This is x value, y value, and this will be the d value. That means the nearest zero cell which is at d distance from this xy box. Here x is 0, y is 0. Okay, x is 0, y is 0, and that means this cell, and let's start first in upward direction. Okay, for this cell x is 0, y is 0, that means this cell first go upward. Go, if you try to go upward, this will be out of the grid. Okay, so you cannot call. Now try to call in this direction, so this is also go out of the box, so you cannot call. Now let's try to call this neighbor, but this neighbor is 0, and we already have done already, and all the we have already done visited, we have already done the answer of that cell. We have already 0 value. Okay, so we cannot do anything. Now let's now try for this cell. This cell is also 0, so we cannot. That means this cell value have already filled. Okay, okay. now now okay, now let's remove another. Okay, and this will be 0 1, x0 y1, x0 y1, that means this cell. Now let's try all the neighbor of this cell. Let's try for upward. This will out of the grid. No chance. In this direction, this is already 0, so this is already done because of 0. Now let's try for that. Okay, in up, that means in down direction. If you go in down direction, you are able to find value 1. If I am able to find value 1, okay, this is 1, and if this will be the 1, so the in visited, and also visited is blank. Blank means there will be no evaluation for this cell. Okay, there will be no evaluation for that. Means if you are able to find cell value 1, and there will be no evaluation in visited, that means visited is blank, that means there is no evaluation. You can fill visited at -1 initially. Okay, but here blank, that means there is no evaluation for this cell. That means here if you are at 0 and you are able to find 1, that means 1. So this 0 1 0, and try for this neighbor. So the new x will be, and new y will be. So the new x and new y. New x will be what? New x will be x minus x plus 1. Here new x will be 1, and new y is also 1. Okay, new x is 1, that means for this new x and new y, the answer will be what? D. Here d plus 1. The answer will be d plus 1. Here d is 0 plus 1. That means 1. That means if this cell is at a 0 distance from nearest 0, then this cell will be 0 plus 1. If this cell will be d distance from nearest 0, then this cell will be d plus 1 cell from nearest 0. Okay, that means the answer for 1 1, the answer for new cell 1 1 will be 1. Here 1 1 will be 1, and 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 also if and also put this value in Q. So this will be 1, x1 y1 and distance will be 1. Okay, this is a simple DFS approach. You will try to do this process or this work until queue is not blank. Okay, or queue is not empty. Now let's remove another. Here x is 0, here x is 0, and also sorry, here we have tried only three direction: up direction, down direction, in below direction. Let's try for the right direction here, but here the cell value is 0. 0 means the already done. Okay, so can't do anything. We have to do only if the cell value is 1. The cell value will be 1 and the visited, that means unvisited cell will be 1 and should be unvisited. Then only you can make solution, and that means we have to fill visited and put in the queue. Okay, this for this we have able to done. Okay, now let's try to remove 0 2. Here 0 x is 0 y2, x is 0 y2 for this cell. Let's try for under. This is go out of the grid, this is go out of the grid, so don't need. Now let's try. This value is cell 0, so don't need to call. This is also 0, so don't need to call. Okay, now let's remove this again. New x row is 0 and y is j is 0. Row is 1, column 0. Row 1 column 0, that means this cell. Now let's call for all its neighbor. This is 0, so don't need to call. This is go out of the grid, so don't need to call. Now let's try for this. Here we are able to find one value. Okay, if we are able to find one value, then let's check is it visited or not. It is visited or not. If and here the value is 1 and is unvisited. Okay, the unvisited, that means need to solve. Okay, so if you have removed that, initially the x is 1 and y is 0. X is 1, yes, x is 1 and y is 0. So for this cell the new x will be and new y will be. So the new x will be what, 2, and new y will be 0. Okay, and for this cell what will be the answer? For this cell the answer will be 1 d plus 1. Here d is 0, so 0 plus 1, that means 1. Here what will be the answer? So new cell the answer will be d, that means here this d, that means at g10 cell we are the nearest 0 is at d distance. So the for new x and new y the d new nearest distance will be d plus 1. Here d is 0 plus 1, that means this value will be 1. Okay, now let's try for, we have try in this direction. Now let's try in another direction. Okay. If you try in this direction, this is 1. Okay, so if yes, we are able to find one value. Now let's check, is it unvisited? Unvisited, that means unvisited. Let's check. Here is 1, but this value is 1. Okay, this value is 1, and one value indicates that it is not unvisited, already solved. Okay, already solved. That means if this is already solved, so no need to solve. If because if it is already solved, so the nearest cell value is already assigned. Okay. So not need to solve. Now we have checked for 0. Okay. And initially, okay, sorry. Here when you put this value, so the solution for this value will we have, that means we must know, we must need to put in q also. Okay, so for this value also put, here is row is 2, column is 0, and the value will be 1. Okay, the value will be 1. Okay, we are forget to put this also in queue. Okay, now let's try for another 1 2 0. That means row 1 column 2, row 1 column, that means this cell. Okay, row 1 column 2. Let's try in all direction. This is upward, already solved because it is 0. This is go out of the grid. Okay, in this direction this is 1. Now let's check it is visited, or that means it is already solved or not. Here this value is 1, this value 1 indicates that already solved. Okay, so no need to solve again. Now let's try in that direction. Here this one, now you are able to find one. Now let's check it is visited or already solved or not. No, this is not already solved, so this, so now need to solve. So this will be this will be the answer for, and the answer will be here new x and new y. So the new x will be what, x plus 1. The row will be increased by 1 in below, so the new x will be 2, and y will be the column will be same, column will be 2, column will be 2. And what will the distance, what will the answer will be d plus 1. D is 0, so for this the answer will be 0 plus 1, that means 1. So the value will be 1, and also need to put 2 row column number 2 and d 1. Okay, so now let's try to remove next. Okay, now try to remove one row 1 column 1 distance 1. That means we are the nearest distance for this 1 cell is 1. Okay, the nearest 0 for this 1 cell is 1. The nearest 0 for this 1 cell is 1. So for remove 1 that means 1 that means this cell. If you are at this cell, try in all direction. This is 0, that means already 0, that means we are not that means no need to solve. This is also 0, no need to solve. This is also 0, so no need to solve. Now check in that direction. Now check in that direction, and this is 1. Okay, if this neighbor is 1, that means maybe need to solve. Now let's check, is it already solved or not. No, it is not already solved. Now let's solve. So the new x will be, what will be the new y? So the new x will be, what is the here, x1 and y1. So the new x will be, if you are going below direction, the new x will be x plus 1. That means x is 1, now increase, that means new x will be 2. And if you go in below direction, the column will not change. Okay, column will not change, that means column will be same, 1. What will the answer, that means what will be the answer for this, the answer will be d plus 1. Here d is 1, so need to increase, so d plus 1, that means 2. That means for this cell the answer will be 2. And so also try to put in q. Okay, now we have checked for this in all directions, 4 direction. Let's remove 2 0 1 2 0 2 0, that means this cell. this cell. Now let's try in all direction. This is 0, that means already solved. Go out of the grid, no need to solve. Go out of the grid, no need to solve. This is 1. Okay, maybe maybe the need to solve. Okay, now if this is 1, let's check, is it already solved or not. Here value is 2, that means not the default value, that means already solved. Okay, so no need to solve. Now remove next to 2, the 2 value, that means this cell. Okay, this cell, check in our direction 0, that means already solved. Go out of the grid, go out of the grid. Okay, now check in the direction, this is 1. Okay, the cell value is 1, so there may be chance to solve or need of solve. Now let's check for visible area. Okay, for that cell, here visible area is 2, that means already solved. Okay, no need to solve. Now let's remove another 210. Okay, 210, 212, 21, row 2 column 1, that means this cell. Now let's try in all direction. This is out of the grid, this is 1, this is 1, but already solved, no need to solve. Here is 1 but already solved, no need to solve. This is 1, so but here already solved, so no need to solve. So this will be the answer, because queue is empty, so this will be the your exact answer, this will be the correct answer. Okay, now let's remove, that means we need to return this visited. You you may you can try to make visited, and that means you try to take two array, one is answer and another will be visited. But in in this in this lecture and in this solution, I try that make visited and answer same, that means try to minimize a space. Okay, now let's implement this code. Okay, let's try to implement the approach to solve, same approach to solve coding question. Okay, initially this is the BFS approach. So first make visited visited array of same dimension of the grid dimension, and one queue, and one is pair class. Okay, pair class, one will be the pair class to solve this problem. Okay, and pair class will contain x, y, d, and okay, you must need how to write this pair class or any class. Okay, I think you are able to write any pair class, any class. Okay, make visited, queue, and pair class. I think that you are able to write pair class. So far directly I have already written on other article. Okay, so let's copy and paste that, and this will be your pair class. There will be need to use this. Okay, and let's first dimension make, for simplicity make this name as array, and number of int m, that means row length equals to dot length, and m equals to n equals to number of column, array of 0 dot length, m row n column. Now let's make visited array of size, and initially by for here 0 and 1 is already given, so maybe confusion. That means if you are going to check visited array, for this cell visited array is already solved or not, you will go we will get default value 0, so we are there is confusion between solved and unsolved problem. Okay, so for that purpose let's fill -1 indicating that for this cell visited array is not solved. Okay, array dot fill visited dot -1. Okay, now let's start array dot fill. Okay, now make 1 2 array. Now next will be what? Now it's table for every cell in the grid, and if you are able to find 0, then you make visited of that cell 0 and try to put this value in queue. And I equals to 0, I is less than plus plus j equals to j is less than j plus plus. If area of ij equals to that means the value will be 0, then in this case visited of ij equals to 0. Okay, visited or answer, visited area or answer will be same. Okay, but to try to minimize space, I have taken the same visited. Okay, that means visited will be treated as answer. And if you are able to get area j equals to 0, make visited ij equals to 0 and put that in queue. For that purpose, make one queue of not integer. Here queue will be of pair class. Queue equals to new, because here we will use queue of pair class. New array dq. Okay, now put queue dot add new pair 0 comma 0 comma sorry ij comma 0. That means if for this ij the nearest cell is at 0 distance. Okay, now to the next, we will try to remove one element until the queue is not empty. That means if queue dot size will be greater than 0, that means you need to remove. Let's remove p equals to q dot remove. Okay, and let's, for simplicity, let's what will the x, y and d value of this? X will be x dot p dot x, y will be p dot y, and d will be p dot d. Okay, now try to call for all its neighbor and I equals to 0, y is less than. That means for neighbor we will try in all 4 direction, and for that 4 direction we will make one row and column array. If you go in upward direction, your row will be -1, column will be same. If you go in upward direction, row will be -1. In right direction, row will be same. In below direction, row will be +1, and in left direction, row will be same. Okay, and column equals to, in upward direction column will be same. In right direction, column will be +1. In below direction, column will be same. But in left direction, column will be -1. Okay, so into new x will be x plus row of I, new column new y will be what? Y plus column of I. Okay, if you, and when you call it, you call only if that means the new x and new y should not go out of the grid, and also the value of cell value, if cell value is 1 then only you can call, and if cell value is 1 and also visited, that means already not solved, then only you can call. We just call only if new x should be greater than equals to 0, and new y should be great, and also new x should be less than what m, and new y should be greater than equals to 0, and new y new y should be less than n, and what if area of I area of new x comma new y must be equals to what cell value 1, and also the visited of this cell visited of this new x and new y must be -1. -1 denote that this cell is not solved, already not solved. In that case make visited of new x and new y equals to 1. Okay, or you can directly fill, if if this condition will be satisfied, then directly put q dot add equals to new pair, and in new pair the value will be new x comma new y and d plus 1 okay. Here d is this distance. If parent is at d distance, the child will be d plus 1 distance, or if the for parent the nearest cell is at d distance, then for child the nearest zero cell will be d plus 1 distance. And if you find this, that means this x and y cell is, for this x and y cell the nearest cell is at the nearest zero cell is at d distance, that means you need to store this in answer array. Answer array is visited, so make this visited of, means for this x and for this y, the visited of xy will be what d, that means this xy will be at d distance, so your answer will be visited, so return visited. I think this code should run. Okay, all is good. Okay, let's what will be x, the cannot find symbol, what symbol, new x, okay, new x, sorry, new x, no, by mistake I wrote new r, area store exception, yes, here I have met one. This is the 2D array, so for that first make for loop. Array dot fill is apply only in 1D array. Okay, one directional array. Now I think this code should run. First make this 2D array and 1D array and then try to fill. Okay, this code is passed for this test case. Let's test for test case. Here find wrong answer. Okay, 0 1 0 1 0 1. The expected as output is 0 1, that means same 0 1 0 1, but our output is 0 1 0 2 0 2 0 2. Why 1 is replaced by 2? Okay, why 1 is replaced by 2? Okay, if you are, that means you here if you remove any element, then after removal you don't direct replace visited. If you only replaced visited, if this replace, that means this visited is not solved. Means okay, that means we have get or one answer, but this one is replaced by some other. That means if you here, if you visited, make visited of xy equals to day, before putting that means before making vxy equals to d, first check this visited is already solved or not. If this visited is not solved, then only put visited xy equals to d. Not solved, that means if this xy will be not solved, that means equals to -1, then only you need to solve. Okay, I think for this will be the, let's use test case. Now check for this test case also. I think this will be the mistake. Okay, nothing. Let's test for all test case. Now okay, this test, that means this code is passed, so this will be the code. I think the video will be of more length. Okay, but don't worry. Thank you.